Hello students, welcome. Today's lesson is on multiplication and division of number bases, of which it goes with a broader topic, operations on number bases. By the end of this lesson, students should be able to solve at least one example relating to multiplication and division of number bases. Now, there are two methods involved when trying to multiply or divide numbers of the same base. And the methods goes with position method, that is method 1, or remainder method, that is method 2. In order for us to go more deep to these methods, let us consider the examples below. There is a problem like perform, that is worked example. Perform 2, 3, 4 base 5 by 2, 4 base 5 and leave your answer in base 5. Meaning that you are trying to multiply two numbers which contains the same base. So to do so, we must first write the question. So 2, 3, 4 base 5 by 2, 4 base 5. After we've written the question, we are going to rewrite the question in vertical form, of which it will go with respect to place value system. We know that this represents ones, this represents tens, this represents hundreds. The same thing applies for this section, ones and tens. Therefore, to rewrite this in vertical form, we have to first write the number that contains the largest numeral. So with this, let us start with 2, 3, 4 base 5 being multiplied, and the second number that has to be written is supposed to be in terms of place value. So the 4 is ones and it has to be under the 4, which is also ones here. So the 4 has been written here. Then we have 2, which is tens. It has to be under this 3, which is also tens. So we have 2. Base 5 has been written like this here. So to multiply, this is how the rule go. We multiply in base 10 form, that is in decimal base. Then the answer will be converted to base 5. In the process of converting the answer, that is when the two methods come in. So we will first consider the method 1, which is position method, when trying to convert the answer in base 10 to base 5. Now, using position method, what this position method means is that we are going to write base 5 numerals up to a number of decades we think of stopping. That is what I mean here. We're going to write base 5 numerals. So for base 5 numeral, we start with 0, 1, 2, 3, 4. For 5, it will be 1, 0, because for base 5, it ends at 4. 11, 1, 2, 1, 3, 1, 4. You go to 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. 3, 0, 3, 1, 3, 3, 4, 4, 0. Let us end here up to infinity. These are base 5 numerals. Then we start with our multiplication. At this juncture, we will say 4 will multiply 4, that is 16. And 4 times 4 is 16. So we count 16 from these base 5 numerals. 0 is not part of counting numbers, so we ignore the 0 here. We will just have to ignore in terms of counting. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 is this number, that is 31. Now, let us write 1, remainder 3. 4 times 3 is 12. 12 plus 3 is 15. So we are counting on the 15th digit. That will be our answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 lied on 30. So this is supposed to be our answer. You just have to write 0 remainder 3. Now 4 times 2 is 8 plus 3 is 11. So we are counting 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 2, 1. So we write, sorry, I've used red pen here. We write our 2, 1 at this juncture. Now we are moving on to the next digit, that is 2. And 2 is multiplying 4, 8. 8 in base 5 using position method. We count 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 1, 3. So you just have to write 3 remainder 1. 2 times 3 is 6 plus 1 is 7. So we count 7. 1, 2, 3, 4, 5, 6, 7. And this is 2 remainder 1. 2 times 2 is 4 plus 1 will be 5. And 5 in base 5 is 1, 0. 1, 2, 3, 4, 5. That is 1, 0. So we continue with the 1, 0. So at this juncture we have to add, and the addition will be done with respect to the same base 5 numerals. Now 1 plus nothing is the same 1. 0 plus 3 is 3. 1 plus 2 is 3. Remember, 3 in base 5 is the same 3. 2 plus 0 is 2, and 1 plus nothing is 1. Okay, so there is an answer when you want to multiply two numbers of the same base. Let us quickly move on to the method 2. That is the use of remainder approach. And for remainder approach or method, for remainder method, it's very simple. It goes like 4 times 4 is 8. So you write your 8 divided by, what base are we dealing in? Base 5. So 8 divided by 5 is equal to 1 remainder 3. Now there is a problem here. 4 times 4 is 16, not 8. So using the remainder method, here is supposed to be 16. So 16 divided by 5 is rather 3 remainder 1. That is the reason I wrote 1 here using the remainder method. The same thing applies to the rest. 4 times 3 is 12. 12 plus the 3 will be 15. Therefore, 15 divided by 5 is equal to 3 remainder 0. That is the reason there is 0 here. And the 3 is somewhere here. 4 times 2 is 8. 8 plus 3 is 11. So it will be 11 divided by 5, which is equal to 2 remainder 1. That is the reason there is 2, 1 here. Using the 10th value, we have 2 times 4, which is 8. 8 divided by 5 is equal to 1 remainder 3. That is the reason I wrote 3 here, and the remainder 1 is also here. 2 times 3 is 6. 6 plus 3 is 9. There is a problem here because 2 times 3 is 6, plus the remainder 1 will be 7, not 9. So 7 divided by 5 means that it is 1 remainder 2. 1 remainder 2. That is the reason we wrote 2 here, and there is a remainder of 1 here. Then 2 times 2 is 4, plus the remainder 1 is 5. So 5 divided by 5, which is equal to 1 remainder 0. So 1 0. That is the reason we have 1 0 here. So the addition goes the same as we applied for the possession method. And this is the answer if you want to multiply 234 base 5 to 24 base 5. This is the answer. You will get 12331 in base 5. Now this is how you have to use the two methods to solve multiplication of number bases. Let us quickly brush through to division of number bases using the same methods. For division of number bases, let us solve. First, we have to write 2, 1, 3, 4 in base 5 divided by 3 in base 5. The same method apply. To divide, first you have to change the division symbol to the bar type, and this is going to be done by simply rewriting it this way: base 5 divided by 3 in base 5. And for division, it is very simple. We have to convert from base 5 to base 10. Then after you've converted from base 5 to base 10, the answers will be divided in base 10. Then the final answer that we will get, we will convert them back to base 5. So this could be done using the expansion approach. And to do this, it is very simple. We go with 2, 1, 3, 4 base 5 all over 3 base 5. And to change it to base 10, you always use the power 0, 1, 2, 3, and this will be always 0. So 2 times base of 5 power 3 plus 1 times base of 5 power 2 plus 3 times base of 5 power 1 plus 4 times base 5 power 0 all over 3 times base of 5 power 0 or 0. This is going to be 2 times 5 exponent 3 is going to be 125. 125. This will be 5 square is 25, and this will be 15. This is going to get exactly 4 all over 3. 3 times 1. The answer has to be 250 here plus 25 plus 15 plus 4 all over 3. And this will go with, this will be, this and this will be 40 plus this will be 190. So 194 divided by 3. There is a problem here. Instead of 294, I made it 194. I have realized anytime I refuse to take my coffee early in the morning, I start to make silly mistakes when solving mathematics. So don't take it that way. Take it easy for me. Anyway, that was just by the way. Now we have 294 and it is dividing 3. And the final answer is supposed to be 98. So now since we want to divide numbers of the same base, we have first changed these numbers to base 10 numerals, and we have divided. When we change the 213 in base 5 to base 10, we got 294. When we change 3 in base 5 to base 10, we got, with this 98, we are going to change it to base 5 numerals. And to change this one, there are two methods involved, as I have already explained, using position method or remainder method. But as for me, I have to adapt to remainder method because that will look very simple and short. For position method, it is your duty to write base 5 numerals up to 98 position. So the answer for 98 in base 10 to base 5 is that you write a base 5 numerals up to, and you write base 5 numerals to certain number of digits. Then you select on the 98 position the particular number which is represented on the 98 position will be your answer. That one will be tedious and involving, and I wish, or I want to give it to us a try whilst you are learning alongside with my solution. For me, I'm adapting to the position, the remainder method. That is why I've written 5 here, 98 here, and R. And for position method, 5 will go into 98. How many times? You just ask yourself, 5 will go into 98 how many times? So 5 will go into 98 19, and 5 times 19 will be 95. So there will be a remainder of 3. 5 will go into 19 how many times? It will go into 19 3 times with a remainder of 4. 5 cannot go into 3, so we can also say 5 will go into 3 0 times, remainder 3. Then we read from down to top. So you can conclude by saying that, therefore, to divide 2, 1, 3, 4 base 5 to 3 in base 5, then your answer is 3, 4, 3 in base 5. That is it, using the two methods, position method and remainder method. For the sake of time, I will pause here. If you want to solve more example, then you can try your hands on these assignments. And this assignment goes with calculate 104 base 6 multiplied by 1530 base 6. Then solve 201 base 4 divided by 23 base 4. If you want to solve more example and to submit the assignment, visit a link I have provided in the description down below. It is a WhatsApp group I've created for my students to help them solve the assignment. Any challenging question that they feel they cannot solve, I guide them, I teach them to solve everything amicably. So make sure you subscribe to this video and click on the bell icon to get notified anytime I release new content which is similar like this. Click on the like button to help YouTube recommend my videos to other people that do not know me. This is Dennis. Tuto tuto is my jargon. Thanks for watching this video. Bye bye. See you soon.